In this problem, I'd like to show you the algebra involved in the problem, but not necessarily the trigonometry. So it turns out that most of the solution to this problem, to simplify this, has more to do with algebra and less to do with trig. To show you the algebra involved here, notice that we have a tan x in both the numerator and denominator. This is where I'm going to make this look more like an algebra problem rather than a trig problem. Let's call the tangent x a and cosine b. Then if you call the tangent a and the cosine b, then this is how you could write the problem. So anytime that you had this kind of structure where a may not be the tangent and b might not be cosine, right? They could be cotangent, secant, sine, etc. As long as you have this general structure where you have a minus b and then ab down here, this algebraic structure could be simplified by doing what I call breaking the fractions apart. So the idea is that I can write this algebraic structure as being equivalent to a over ba minus b over ba. Now you're probably used to doing the opposite of that. You're probably used to starting with this and being asked to subtract the fractions. And if you remember how that goes, you can subtract fractions as long as they have a common denominator. Since both these denominators are ba, you could subtract these two fractions by simply taking a, subtract b, like this, and then just writing down the common denominator. So you're used to going from this structure this way. I'm suggesting that it's just as legal to take this as your start and go backwards and rewrite it as follows. Of course, now that we've split them apart, a is both a factor in the numerator and denominator. Now the original problem, it would be not correct to cancel the tangents and the cosines, because the tangent and cosine is not a factor in the numerator. For example, cosine is a factor in the denominator because this is multiplication, but cosine is not a factor in the numerator because it's not being multiplied. In fact, when two things are separated by an addition or subtraction, those are called terms, not factors. In mathematics, you can cancel factors, but you cannot cancel terms. So the fact that this cosine is a term, not a factor, means you cannot cancel it in its current condition. But now that we split the fractions apart, the idea is that the a is being multiplied by b. A is a factor in the denominator. And if you want, a is being multiplied by 1 up here, so a is a factor in the numerator. They're not terms, they're factors, and therefore you can cancel them. That would leave you with 1 over b. And then the same logic applies over here. B is a factor in the numerator. It's being multiplied by 1 if you want. And b is being multiplied by a. So b is a factor in both the numerator and denominator, and therefore you can cancel them. A better way to say it is to say that b divided by b simplifies down to the number 1. And if you simplify b over b to be the number 1, you'd be left with 1 over a. So most of the simplification of this problem really is algebra, not trigonometry. So if you applied this logic to this problem, it would look like you're taking the tangent of x, it's being divided by cosine tangent, but we also have the cosine is being divided by cosine tangent, and we are to subtract these. So it's likely the case that you're used to the situation where you're given two fractions with a common denominator and you combine them via the subtraction and hence go this way. We're just doing the opposite and we're splitting them apart. Once they're split apart, the same logic applies, that the tangent, even though it was not a factor in the original problem, right, it was a term and you cannot cancel terms, it is a factor now. The tangent's being multiplied by the cosine, and in terms of just this fraction here, the tangent in the numerator is a factor. It's being multiplied by 1, and thus we can simplify down and say the tangent of x divided by the tangent of x is 1. You'd be left with 1 over cosine, and then here the cosines simplify to be 1, and you'd have 1 over tan x. So I feel like I've done no trigonometry so far, and I said at the beginning of the video that I wasn't going to help you with the trig, just the algebra. So far no trigonometry took place. It is essentially algebra. Now I'll leave it up to you to simplify further and identify what 1 over cosine can be written as and 1 over tangent of x. So we want a single trig function here, and we want a single trig function there. So hopefully this video was helpful.